Okay, welcome to part 2 of climate change. We will again be having a 15-minute Q&A at the end, and for the video viewers, again, I would urge you to make sure that if you're looking at something, you understand the context of it and watch part 1 and part 2 because there's a lot of tie-in between the two. So in part 1, we covered theology, history, and CO2 science and climate science. Now we get into the fun part. Okay, part 2, we get into the climate controversy. This is where we do the he said, she said stuff, okay? And then we'll get into a little bit of economics and talk about energy and transportation, because those are all tied in with global warming or climate change, because they want to decarbonize everything. So the first to present his case seems right till another comes forward and questions him. So you always want to make sure you hear both sides of the story. You don't want to convict someone before you hear the defense case, or vice versa. And the Lord wants you to be honest in your testimony. Okay. There are two main climate camps. The alarmists, who think that anthropogenic greenhouse gases are going to lead to a catastrophic outcome, and the skeptics, who say there may have been some warming, but it doesn't seem to be headed toward catastrophe, and they don't want to have a definite economic catastrophe to avoid a hypothetical climate catastrophe. And I do not know if they're going to drink any particular fizzy beverage with that roast penguin or not. I can't read the labels on those bottles. Speaking of polar bears are doing fine. The main problem with polar bears was they were being hunted, and the 5 Arctic nations got together in '73 and said, okay, we can actually agree on something, and we won't hunt polar bears anymore. And generally since then, they've been doing okay. There was concern that the reduction in summer ice was going to hurt them, but the polar bears seem to be doing fine. People are asking, why was 2023 so warm? Well, maybe this is a clue. You have to be careful. Correlation is not always causation. If you look on the left, these are going from 1979 to 2014, and we see UFO reports increased dramatically in that period, and so did ocean temperatures. So, perhaps there is some tie-in, I don't know. But anyway, just be careful about things like that. I've heard that sharks like ice cream because shark attacks always seem to occur in summer when ice cream sales go up. What do the ice core records say? This is an ice core. You may have heard about this. In Greenland and Antarctica, Siberia, and any place they can find thick ice, scientists drill in, and then they examine the impurities and the isotopes and the gases in the little tiny bubbles, and they try to figure out what the past climate was like from that. And so here's one of their results. We don't agree with the chronology here, okay? This is done by scientists who believe in, billions and billions of years, and, if you get multiple snowfalls in a year, maybe they think that's multiple years. Evidence that snow piles up pretty quickly was in Greenland in World War II. Some U.S. Planes had to do an emergency landing in Greenland in bad weather, and the airplanes crash landed on a glacier, and they just left the planes there. They did rescue the crews, and a few years back they wanted to get those planes out and try to restore them. They had to go down 250 feet to get them. That was from World War II. So yeah, that stuff can build up pretty fast. I'm curious what the ice core would have determined the age of those planes to be. But the interesting thing here is the relationship. If you look, according to the ice cores, temperature increased here, and then after temperature increased, carbon dioxide went up, and then temperature decreased, and then after the temperature decreased, carbon dioxide came down. So I guess I'm curious what the cause and effect is there. As I said, there's an awful lot going on in climate, and we don't understand much of it. And carbon dioxide is a greenhouse gas, but there's a lot of stuff that's doing things beyond that. Okay, what is the ideal climate? Cold is more dangerous than heat. According to the study of the Lancet, when you're looking at longer term exposure, not necessarily that Buffalo snowstorm at the beginning, but when you're looking at places that have severe winters versus places that don't, cold kills 20 times more people worldwide than hot weather. So, you know, we talked earlier about, you know, milder weather and stuff. Milder weather is better for your health. And then also, I think I mentioned it earlier, biodiversity is greatest in the tropics. 80% of total species on this planet are found in the tropics, almost nothing at the poles. So stuff besides humans like mild weather. Truth is not a popularity contest, both in theology and science. If you remember Jeremiah, the Old Testament prophet, was not a real popular guy. He prophesied what God told him to prophesy, and everybody said, "You must die because we don't like what you're saying." And a guy by the name of Michael Crichton, who is famous for the Andromeda strain in Jurassic Park, also had an interest in actual real science, kind of like Tom Clancy writes his novels, but has an awful lot of knowledge about real world military stuff, and has to be careful what he says, because some of that is based, the Pentagon says, hey, wait a minute, that looks like classified material. He had to prove it wasn't. But anyway, he said there's no such thing as consensus science. If it's consensus, it isn't science. If it's science, it isn't consensus, period. He's unfortunately passed away a few years ago. Okay. Those of you familiar with Brave New World might recognize this and think, hey, wait a minute, that sounds like what's going on today. The controller says, yeah, science leads to instability, science is dangerous, we have to keep it most carefully chained and muzzled. And the response is, but we're always saying science is everything. Ah, yes, but what sort of science? I was a pretty good physicist at the time, too good enough to realize that all our science is just a cookery book with an orthodox theory of cooking that nobody's allowed to question, with a list of recipes that mustn't be added to except by permission from the head cook. So if you wonder why climate science and evolutionary science is popular, it's because there's an approved book of recipes, and if you're not cooking from that book of recipes, you can't cook. Oh, the 97% consensus. Okay. I'm sure you've all heard about the 97% consensus. Okay. So this paper on the top half of the slide there is the origin of that 97% consensus. So quantifying the consensus on anthropogenic global warming, John Cook and a whole bunch of other people. And then it mentions abstracts. Abstracts on a scientific paper is kind of the head paragraph that the authors write, and they say, here's a quick summary of what the paper is, so you can read that to see if you want to spend whole lot more time reading in the contents. Okay, so the abstracts are very worthwhile to kind of scan things and get an idea quickly. So that top part is a literal quote from the abstract of that paper. And they talk about the different percentages. They scanned other abstracts of scientific papers having to do with global warming to find out how many of them blame humans and how many of them don't. Okay, so basically they're saying 2/3 of the papers they scanned that were dealt with climate change expressed no opinion. 1/3 did, but the way that they endorsed it was anything from kind of admitting it exists to sort of implying, well, maybe humans might possibly have something to do with it, to probably the people who said, oh, absolutely, there's no doubt in my mind humans caused it. But the thing is, they lumped all that together. So what I've done is I've translated that, seeing as this is a lot of politics going on and a lot of polling going on. Think about candidate named whose initials are AGW, and somebody calls you up and takes a poll, and they publish the results of that poll, and they say, okay, here's what we've found surveying voters on support for candidate AGW for a particular office. Okay, 66.4% of voters expressed no opinion on candidate AGW, 0.7% would not vote for him, 0.3% were uncertain, 32.6% expressed some level of support ranging from, well, maybe I'll think about voting for him, to, oh yeah, absolutely, I'm gonna. None of the voters thought AGW would be the end of democracy. Therefore, the election is over. AGW has been declared the winner with 97.1% of the vote. Okay, that's basically what that paper is saying. That's their methodology. Okay, we've taken a poll, 2/3 don't express a preference, but of those that do, anything from, yeah, I might consider voting for that person, to absolutely means, yeah, that's a definite vote cast, and we don't care about the other 2/3. We're just going to take that and say, okay, 97%, that's it. So now you know where the 97% comes from and how they got there. So it's basically bogus. Okay. Speaking of polls and popularity contests, 95% of climate models agree that the actual temperature measurements that we're taking must be wrong. If you look at those two, this is UAH, which is the more reliable of the two. These are all start at 1983, and so he's plotting all the different climate model predictions, and there's reality, okay? 95% of the models agree that reality must be wrong. So I guess reality's wrong. Here's an interesting book. This came out in 1931. It came out in Germany. There was a bunch of scientists who weren't particularly fond of Einstein's theory of relativity. And so they said, hey, 100 of us agree you must be wrong. That's what that says. 100 Autoren gegen Einstein, 100 authors against Einstein. That was actually a real book. That's a picture of the cover page, okay? And his response, being a good scientist, he says, why 100? If I were wrong, then one would have been enough. All you need is one person to prove you wrong. It's not a popularity contest. Technology giants are not neutral. I mentioned earlier that at the beginning that Bill Nye video had the United Nations sing underneath and said, hey, you better check out what the United Nations has to say about climate change before you go forming your own opinion. Okay, this is the UN resolution establishing the IPCC as intergovernmental panel on climate change in 1988. And if you look at the wording there, they basically say we need to assess the scientific information related to the components of the climate change issue, such as greenhouse gases and the radiation balance that I talked about earlier, and formulating response strategies for the management of the issue. They've decided that there's an issue and that needs study and management. They're not investigating to see if there's an issue. They've already decided there is an issue. So it's kind of like we've made up our minds, it's kind of like we, the jury, have made up our minds, now go hold the trial so we can vote. Climate science is highly politicized. This is a very esteemed professor who is, I would put in the skeptic camp, from the underneath the polar bears, the alarmists and the skeptics. But he's a very prestigious person, and he took part in the, what year was it? Yeah, that was the, oh yeah, it was the same year. Okay, 2001 for both his testimony and the participation. Yeah, the IPC coordinators would come around and you basically saying, don't criticize the models, the ones that said reality's wrong, okay? And you have to say the models might still be correct despite the cited faults, okay? So don't believe your lying eyes, go with the models. And this is just a cartoon based on, this is just government in general, or this is just human nature really, okay? IPCC meeting. Hands up, who thinks greenhouse gases have no effect and therefore we all need new jobs? Anybody want to vote themselves out of a job? Okay, that's just human nature, right? So, okay, what I'm going to be doing is presenting from those UN links. I'm going to be pulling quotes from them, okay? So UN, what is climate change, : and then there's a quote from it. But since the 1800s, human activities have been the main driver of climate change, primarily due to the burning of fossil fuels like coal, oil, and gas. Well, they don't explain how this other stuff happened before we started emitting a lot of carbon dioxide. Again, the last decade is the warmest on record. Since the 80s, each decade has been warmer. Nearly all land areas are seeing more hot days and heat waves. Okay, we talked about this earlier. You see any uptick in hot waves and heat waves here? No, we had it in the 30s. We're not having an uptick in hot wave. We had a little dip in the 70s. That's when everybody got upset and said, we have a climate crisis. We need to heat the place up. Again, another quote. Destructive storms have become more intense and more frequent in many regions. As temperature rises, more moisture evaporates, exacerbates extreme rainfall and flooding, causing more destructive storms. Okay, here's the actual historical record of hurricanes landfalling in the US. This starts from 1897 up to 2017. Okay, category 1, 2, 3, 4. You see any upward trend there? I don't. But then again, don't argue with models. Climate change is changing water availability, making it scarcer in more regions. This is from, again, 1895 to 2023. This is percentage area of the US that is wetter than normal or drier than normal. See a long-term trend there? Melting ice sheets also cause sea levels to rise, threatening coastal and island communities. This is just a web page I pulled off of Maldives. Have you heard of that? That's the Indian Ocean island nation that is barely above sea level. The highest elevation, I think, is maybe 4 feet or something like that. It's just barely above sea level. And they're saying, oh, that's going to get inundated and buried. I pulled this off just a day or two ago. They're showing 66 offers of different vacation resorts and packages all over the Maldives. There's over 1,000 islands in that chain, okay? And this was intentional. That was not inundated recently. If you ever see the sandals commercials, they show a lot of stuff like that. Okay, that's not sea level rise. People just enjoy being out over the water, okay? So the reports of the drowning deaths have been greatly exaggerated. And you may have heard about Greenland and Antarctic ice losses, okay? Greenland is losing 269 gigatons of ice, Antarctica 142 gigatons per year, okay? But it is a big planet and if you try to find the total size of those ice sheets, you won't find it. I looked all over the internet, couldn't find it. I had to compute it. I found enough information to figure out the volume and then the density and stuff. So that's the total size of Greenland. That's the total size of Antarctica. Current rates of melting. Now this is over the last 20 years. This is about a 20-year average. Okay, so this is not like just some little blip in the data. If it keeps going at the current rate, in a mere 14,000 years, Greenland will be melted. In a mere 168,000 years, Antarctica will melt. So, as I said before, ocean levels are rising. Warmer weather will cause more of this to melt, but it's been very gradual and no major increase. And so, I mean, that could be a problem for low-lying areas, but a lot of that is due to subsidence. Like Indonesia, I think, is relocating their capital city. It's not that the ocean's rising, it's that their city is subsiding because they're pumping out so much groundwater. The ground is literally settling, and it's just kind of like a sinking ship. The ocean isn't rising, the ship is sinking. That's the case in a lot of areas because they pump out groundwater and do mining and stuff. Oh, the other thing is the Earth is not like a hard rock. The Earth is more like a water balloon. So if you poke it in one place, it bulges somewhere else. So that puts a lot of complications into trying to measure ocean level, because if a glacier melts somewhere, that's less force on the Earth, and locally the land will actually rise up because the glacier isn't weighing it down. So the sea level will actually drop where the glacier is melting, and that'll get distributed over the rest of the planet. In addition, the ocean absorbs carbon dioxide, keeping it from the atmosphere, but more carbon dioxide makes the ocean more acidic, which endangers marine life and coral reefs. Ocean pH averages 8.1. If you're familiar with the pH scale, 14 is as alkaline or as basic as you can get, and 0 is acidic as you can get. This is slightly basic. We don't know, pH meters are a modern invention, so we don't know what it was hundreds of years ago. A best guesstimate is that perhaps in the last few hundred years it may have reduced by 0.1 on the pH scale, but it's nowhere close to being able to go into acidic zone. And if you remember that carbon cycle earlier, there's not enough fossil fuel in the ground to turn the ocean acidic, even if we took it all out and immediately dumped it in. Rainwater is 5.6. So, and the other thing is sea life is very healthy at current slightly higher CO2 levels. Forest fires, extreme weather, and invasive pests and species are among many threats related to climate change. This is U.S. acres burned in the U.S. starting at 1920 to 2020. This is a century of forest fires. This is, I think that's 50 million and 10 million. So most likely this is more likely due to poor forest management, because as people want to leave nature alone, what happened, remember God told us to take care of the garden. He didn't say let it grow wild. And there's been a lot of forest mismanagement in the last few decades, and that's why you're seeing more fires, because they just let the underbrush grow and the dead trees sit there and such, when some of that could be valuable timber and stuff, and they, nope, can't touch it, let it rot. Oh, wait, oh, forest fire came. Ooh, too bad. But worst wildfire in U.S. history was October 18, 1871 in Peshtigo, Wisconsin. 1,500 to 2,500 fatalities, 1.2 million acres burned. A lot of people don't know about the Peshtigo fire because this little thing called a Chicago fire occurred the exact same day. Okay, changes in the climate are among the reasons behind a global rise in hunger and poor nutrition. We saw these graphs earlier. Yeah, global food production just going in the tank. This one is the one that bothers me a lot. Climate change is the single biggest health threat facing humanity. That is just a declarative statement saying that is the single biggest threat to health on the planet. There's an organization you may have heard of called the World Health Organization, WHO. And the rules by which WHO operates are, and this is not an Abbott and Costello joke. Unfortunately, I wish it was, who's on first. The rules that they're planning to amend in a few months are going to allow the WHO to declare a public health emergency of international concern, which would enable them to issue legally binding instructions to states, meaning nations. Boy, what government organization doesn't want more power, or what government organization would let a health threat want to go to waste when they could take some power? They already have an infodemic unit through which it enlightens states about what, in its opinion, amounts to health myths or disinformation concerning those incidences. So it's a good thing we're having this now, because I don't know if we'll be able to in the future. We might not. They might consider this seminar disinformation. I'm concerned about that. Post-normal science. You may have heard of postmodernism, the death of truth, and everything. Truth is relative. Well, now we have post-normal science by bringing facts and values. Values? Wait a minute. Science is supposed to be neutral. Into a unified conception of problem solving, replacing truth by quality. Wait a minute. Replacing truth? That sounds strange. That's the Encyclopedia of the Earth. And this is a long quote, and it says, self-evidently dangerous climate change will not emerge from a normal scientific process of truth-seeking. So we need to trade normal truth for influence. Climate change is too important to be left to scientists, least of all the normal ones. Yeah, like Einstein, you know? I don't know. Yeah, he was a normal science. Okay, that's by the founding director of the Tyndall Center for Climate Change Research and a professor in the school. So that's, speaking of people in the business. Phil Jones, you might have heard of ClimateGate. I think he was one of the people involved in that. He says, even if the World Meteorological Organization agrees, I will not pass on my data. We have 25 years invested in that work. Why should I make the data available to you? Your aim is to try to find something wrong with it. I thought that's what science was supposed to be about, you know? Trying to prove each other wrong, you know, submit it to impartial peers, but that doesn't sound like a neutral scientist to me. There are some problems with some of our weather stations. That little thing right there is a weather station. Those are supposed to be out in the field away from any human influence. You have walls around it, you got a refrigeration unit, vents, you got an air conditioner. I mean, there's just all kinds of stuff wrong with that, which is one of the reasons some of our recent temperatures are showing higher than maybe they should. Remember 1984, the novel by George Orwell? Who controls the past controls the future. Who controls the present controls the past. The main character in there was Winston Smith. His job was to rewrite the past and then put the real past in the memory hole so it would get incinerated with no trace. Well, that's what's happening to our climate records. That dark trace at the top is the original trace from Central Park, New York. And then it got revised and revised again, and because they just can't leave reality alone. So they're rewriting our temperature records. At the beginning I said, you can't find that NAS chart anymore. Yeah, because it's been modified. Climate changes to temperature records. Climate for You website divides temperature records into 3 quality classes. UAH, which is the one that I used, and RSS both use satellite records. UAH, I think, is a little bit better. RSS is a little bit off, but not too bad. HAD-CRUT is based in the UK. And then NCDC and GIS, Goddard Institute for Space Studies, and I forget, National Climate Data Center, I think, are in the US. These are adjustments that NCDC and GISS have made to historical climate records. These are from, the two records in question are January 15 temperature records versus January 2000. There's January 2000, January 1915. They started out here, and then they got adjusted and adjusted and adjusted and adjusted and adjusted and adjusted. They just can't leave well enough alone. And GIS does the same thing. Here's January 2000, there's January 1910. They got to just keep adjusting history, keep rewriting history. So, and you notice what they're doing. They're making history colder and recent temperatures warmer so that you see more global warming. Told you this was going to be controversial. Who's correct? Who's the false prophet? Test everything, hold on to the good. How can we know when a message has not been spoken of the Lord? If what a prophet proclaims does not take place or come true, that is a message the Lord has not spoken. The prophet has spoken presumptuously. Do not be afraid of him. So, science, field of study concerned with discovering and describing and experimenting. Religion, a cause or principle or system of beliefs held to with ardor and faith. And then, I think I got this from somewhere else. However beautiful the strategy, you should occasionally look at the results. Summary of the scientific method. Formulate a hypothesis, make falsifiable predictions based on it, conduct observable, repeatable experiments to test it. If the predictions are correct, you accept it as tentative truth. Science is always tentative. If it's false, hypothesis must be rejected or modified until you can confirm or affirm new predictions. So let's look at some of this stuff. Okay. You may have heard of the hockey stick, the climate hockey stick. This is the famous hockey stick. It was put out in a paper by Michael Mann and a few other people, and basically it goes from the year 1400 to 1980, and it says all during that time climate was just rock steady, rock steady, rock steady. All of a sudden when recent times came up, it shot up like that. So this is the handle of the hockey stick, and there's the blades. That's how it got its name, hockey stick. Well, a couple of Canadian guys took a look at that and said, boy, that just seems strange. Can we look at your data and double check that? And amazingly, they got access to it. You won't get access to it now, probably. But they went in there and they looked at the raw data, and they looked at the mathematical stuff, and they said, this stuff doesn't make sense to us, because no matter what we put in, we can put in anything we want and we still get a hockey stick. We could put in random numbers and we get a hockey stick. Not only that, but this was done with tree ring proxies, and some of these, they weren't lined up correctly chronologically, and some were put in there that shouldn't have been. And so they said, well, we think we fixed the errors, and now it looks like this. And this would correspond with the medieval warm period. This would be like the little ice age here, and here would be modern warming. And so just so you know, there are different perspectives on things. Different types of models. Finite element models. Okay, you may have seen examples of this. Engineers use these things a lot to design things. Okay, when you design airplanes and bridges and cars and stuff, you use a lot of finite element analysis because you want to optimize the design. You want it to be strong enough, but not too strong or heavy and wasteful or whatever. Like airplanes only have a 10% safety factor, which means if you overload the wings by more than 10%, they break. Because if you make them any heavier, the airplane doesn't fly well and uses too much fuel. So believe me, they tune that very precisely. Climate models, on the other hand, are pretty much that. They are empirically falsified, and they can't model clouds. So that's what climate models are. You've seen they don't work. Danger of post hoc theorizing. See, now if you shoot holes in a barn and then you paint targets around it later, you look pretty good. And if you remember that 97% consensus paper, Skeptical Science is the website that the guy founded, John Cook, okay? So he says, all our models are first tested in a process called hindcasting. So if they can accurately model history, then we think they should be good for the future. Well, okay. So some wise guy named Warren Meyer says, okay, well, how accurately do they do in history? So he said, okay, this is pre-industrial age, back in the 1800s. This is today. And if you don't have any amplifying effects on carbon dioxide, we would expect to see a graph like that. And this pretty much matches what we've observed for the last 150 years. But the climate models, which predict much greater warming, if you say, okay, you're real sensitive to more carbon dioxide going forward, we're all going to cook. Well, okay, so by the same reasoning, if you go back in if you go back in history, it means we should be freezing. So use the same climate model that says we're all going to die from heat, but that says we're going to freeze there, and there's history. So they don't work in hindcasting either. Not only that, but if you remember that chart that showed it warmed up into the 1930s and cooled into the 70s and then warmed up again, yeah, climate models cannot reproduce that. They're just kind of we're just more straight line guys. I'll show you that in a minute. Okay, this is, in a minute, we'll do this, a demonstration of this. So what's real science and false religion? The alarmists say that if you double carbon dioxide, yeah, the nominal might be just 1.1 degrees, but there's all these feedbacks that are going to amplify it and just make everything be unstable. Whereas the skeptics say, well, no, we think God well, they don't always invoke God, but we think there's some negative feedbacks in there that dampen out the effects so that it's not as bad as you say. So I would like to physically demonstrate for you what a positive and negative feedback is, and hopefully that will help you understand when everybody's talking about that stuff. Let me just get to the right spot here. Okay. So, let's go back here where we have a little elbow room. Okay. So, this yardstick, I'm going to balance it on my hand. And when I balance it on my hand, I'm going to try to keep it upright. But gravity is going to want to make this fall. Gravity tends to do that. The more this thing tips to the side, the more gravity wants to make it fall, right? If I try to, if I put it vertically, it's not much effort to keep it vertically. If I put it sideways, I have to put a lot more force on it here to keep it sideways, because there's this long lever here, and gravity really wants to make it go down, okay? So this is a positive feedback, okay? So if I try to balance this, and Dave comes along and gives it a whack, it goes, he didn't even have a chance to give it a whack. It went unstable by itself, okay? So that's what happens in an unstable system when you have positive feedbacks, okay? You get the slightest little error and things go bad. And that's what they're saying our climate is. They're saying our climate is like a tightrope walker, okay? One little boo-boo and you fall to your death. That's what a positive feedback is. If you look at the pendulum on your grandfather clock, it's like this, right? This is a negative feedback mechanism. You want to hit that again? Yeah, it doesn't fall over. Mm-hmm. Yeah, how about that? It doesn't fall over. You know what? I forgot to bring my little fan up here.
Yeah. I was wondering where you put that.
Okay, it's in my computer case. Okay, the point, you get the main point. If I blow on this hard enough, I can make it, okay, so if carbon, so let's say this is our climate, and it's nice and stable like God designed it to be. If we put a lot of carbon dioxide into it, we can get it to move a little bit as long as I keep blowing on it. As soon as I stop blowing, it goes back vertical, okay? So this is the way God designed climate. This is the way the alarmists say climate is. So negative feedback, positive feedback. Tightrope walker, grandfather clock pendulum, okay? So if anybody tells you we're balanced on a knife edge, tell them, is your grandfather clock pendulum balanced on a knife edge? Well, yeah, but it's pretty, I mean, there might be balanced on the edge of some kind, but it's pretty stable, and so is our climate. So we can get our climate to deviate a little bit, but it doesn't want to deviate, it wants to come back. God designed it very well. Predictions. In fact, there are no predictions of climate models. There are only projections. And they do not consider many things like recovery of the ozone layer or a bunch of other stuff. And he says, none of the models used by the IPCC are initialized to the observed state, and none of the climate states in the models correspond even remotely to the current observed climate. What? I thought this was a climate model. It doesn't correlate to the current stuff? What's he talking about? Current projection method works to the extent it does because it utilizes differences from one time to another, and the main model bias and errors are thereby subtracted. This assumes linearity. Remember I said they can't model the dips and the bumps? No, they can't. Matter of fact, it cannot work for many aspects of climate. They don't realize how many aspects it doesn't work for, especially those related to the water cycle. So this is a major challenge. Remember I talked about that heat pipe before in that one model? That actually, Kevin Trenberth, he's one of the guys that put together that picture, okay? And he says they can't model that heat pipe. They can't model clouds. Clouds are a negative feedback. They can't model clouds. They can't model all kinds of things. They're basically just going on mostly a straight line and saying, well, I want this straight line to have this slope, therefore it will. This was one of their predictions right here. A while back, they said, if our theories are true, above the equator, you should see this kind of like giant donut of hot air circling the equator, kind of like a ring on Saturn, okay? So if you looked at temperature, remember that FEA model, you know, had different colors for, you know, this is different temperature, different colors for different temperatures. So they said, it ought to look like this, okay? This is the equator, this is about 12 kilometers up in the atmosphere. You ought to see this big hot donut, this is a cross section. You ought to see this big donut circling the planet. Well, they went up and measured it and it looked like this. So I guess climate models and reality do not match. What about the basic premise of their models? These are graphs of radiation coming out of the upper atmosphere. And according to their theories, if you get more carbon dioxide in the atmosphere and the ocean heats up, you should see less radiation coming out of the top of the atmosphere as the ocean surface temperature heats up. So on this axis is ocean temperature from cooler to warmer. On the vertical axis is the watts per square meter of radiation coming up, that infrared that I talked about going through the obstacle course. Okay, so these 11 are climate models, and they say as the ocean gets warmer, you ought to see less radiation coming out of the top of the atmosphere. This is what an actual satellite measured it to be. So this is reality. These 11 are climate models. Do you think they agree? The slopes are opposite. Continued adherence to a demonstrably false belief is religion or delusion. There's a lot of delusion going on. If you read 2 Thessalonians 2, 9-12, if you reject the truth, God sends you a powerful delusion. That holds true in both theology and science. We talked earlier about Judeo-Christian theology, environmental alarmist theology. Many of them will actually talk about Gaia, the earth goddess from ancient Greek mythology. And the earth is their god, okay? Evil, instead of being Satan and human sin, it's humans themselves, and CO2 and fossil fuels and nuclear energy just for giggles. Imperiled and redeemed humans, nature. They care about nature, not humans. Intermediaries are the priests and Jesus. For them, it's the elites, World Economic Forum. See, I told you that was coming. And scientists. Temple location, Jerusalem, Davos. Redemption, divine sacrifice, Jesus. Redemption, economic sacrifice, decarbonization, human sacrifice. There's a lot of them that are literally saying humans are a cancer on the planet. And the earth would be better off with 90% less humans. So our view toward toward earth is, remember we said it's your house? For them it's their God. And if humans can't achieve symbiosis, they must be removed. We look to our apocalypse. I know there's variations in eschatology, but Jesus returns and eventually unbelievers are thrown into the lake of fire. Their apocalypse is a climate apocalypse. They're worried about nature getting harmed, not so much about people. And even if they are well-intentioned, it won't work out. It may not work out well. C.S. Lewis, God in the Dock, Humanitarian Theory of Punishment, he says, the tyrants that are well-intentioned can actually be worse than the ones that are evil, because the robber baron's cruelty may sometimes sleep, but those who torment us for our own good will torment us without end because they have the approval of their own conscience. So when they're worshiping a different god, they might be just following their religion. If Earth's climate was inherently unstable, how did it manage to go for thousands of years without going into a permanent extreme of hot or cold long ago? As someone who's studied and dealt with control theory, this is just a really big question for me, okay? I mean, maybe it's not for you, but for an engineer, it's like, I don't get it. And we started with a climate crisis with Leonard Nimoy from the 70s. We'll end with one. This is from 1975, New Ice Age. Just so you know, that wasn't an outlier. There's a whole bunch more of these around. Significant shift in climate scene, new ice age dawning. Change of climate, even if sustained for a few years, could seriously disrupt the way we used our resources. The scientists said in the report released by the National Academy of Sciences. We simply cannot afford to arrive unprepared at the doorstep of a natural or man-made climate catastrophe. They reported, without a doubt, colder climate will come. They also expressed concern over the increasing importance of man's effects on climate, but they said it's unclear whether the increased levels of carbon dioxide will alter temperature. So they've changed a lot since then. Okay, climate economics. Supposedly, burning fossil fuels and climate change are going to be bad for humankind. This data was gotten from an agency sponsored by the UN, okay? It's just been graphed by Human Progress. 1925, average yearly climate-related deaths in 1925, about 500,000. This is global, okay? 1925. 95 years later, it was 15,000, a drop of 97%. So have fossil fuels made our life on this planet related to climate more dangerous or less dangerous? And oh yeah, during that time, world population almost quadrupled. So this is just an absolute basis. Population almost quadrupled in that time that these deaths were falling 97%. Too often we listen to environmental experts and ignore energy experts, cars and traffic deaths. Most of you probably came here by car. 50,000 people a year die in the US by cars. Should we ban cars? We could save 50,000 lives a year. But most of us recognize that the benefits outweigh the costs. Same thing with energy. Energy provides incredible wealth to us that our ancestors couldn't even dream of. 4 Pillars of Modern Civilization, How the World Really Works by Vaclav Smil. I just want you to know who Vaclav Smil is, okay? This is the book that came out of, okay? Right here it says, there's a quote from a famous person, okay? I'll read you the quote. It says, "There is no author whose books I look forward to more than Vaclav Smil." Bill Gates. So this guy is not a household name, but among people who study energy and environment issues and stuff, this guy is well known. He's written about 40 books. He's kind of an eccentric character, but he just has an amazing way with facts and communication. So he says there's 4 things that are essential to a modern civilization: ammonia, plastics, steel, and cement. Can you imagine life? Well, the thing is, you may not be familiar with ammonia, but nitrogen fertilizer is made with natural gas predominantly. And if you talk to any farmer, a relative of mine is a farmer. He talks about going to get ammonia to put on the fields. Why? Because nitrogen. If you look at fertilizer, the big 3 nutrients in fertilizer are nitrogen, phosphorus, and potassium. Nitrogen is by far the most important. So nitrogen fertilizer feeds the planet, and it's mostly made using natural gas. Plastics are like literally made from oil, mostly oil and a little bit of natural gas. Steel is produced using coke. That's not the beverage. That's kind of more of a charcoal type of a thing based. They use coal as the raw material and drive off some of the more volatile stuff. And then cement, which is used to make concrete, is made by firing limestone and clay at very high temperatures, almost always using fossil fuels. Economically, none of these can be made today without fossil fuels. Imagine life without food, plastic, steel, or concrete. You can make some of these without fossil fuels. How much do you want to pay for your next car or washing machine or road or anything that's made out of plastic, your clothes? Poverty kills. Many people in Africa cook their food using animal dung, contributing greatly to lung and other diseases. Can you imagine going in your kitchen and instead of turning on your stove, burning some animal dung? Can you think what that would do to air quality? It's a serious health issue in Africa. The use, are you familiar with it, like a propane camp stove? You can provide those at relatively low cost to a lot of poor people in Africa and save a lot of lives, but it's fossil fuel. A lot of African babies are lost due to the lack of affordable, reliable electricity for things like ultrasounds and incubators. If you don't have reliable, affordable electricity, the medical institutions don't bother buying it, because why would you buy it? You can't plug it in. Denying them access to energy costs energy costs lives and inhibits progress. When societies get richer, they take better care of the environment. That's very well established. Energy and transportation. Yeah, you need to, LCOE. You may hear that, levelized cost of electricity. You see the graphs, or they talk about it, and they say, solar is so much cheaper than anything else. Its costs have come down so drastically. We ought to just switch over to solar. Problem is, they're not considering LACE. This is cost. This is revenue. If you can't make money if you can't sell products. What happens during Dunkelflaute? Dunkelflaute is a German word. It means dark calm. Germany gets those every once in a while, several times a year. There's no specific definition of it, but common. One scientific paper said we'll define it as both solar and wind producing less than 20% of their rated capacity. So what are you going to power your country with when the solar and wind are both dead? And Germany economically is suicidal. It's very sad. Their cost of energy, if they didn't have France to bail them out with France's nuclear energy and Poland and other people to take some of their excess energy when they're running full tilt, they'd collapse. Examples of these concepts are kind of hard to understand, so I just pulled up some graphs. Okay, here's your costs, here's your revenue, right? Your revenue has to exceed your costs, so you have to, if you want to survive economically, you have to be above that line. So natural gas, the red dots are actual installations. They're always on or above the line. But you notice wind and solar often are not because they're not working based on economics. LCOE for wind and solar generally, they don't often include the cost of they talk about battery backup, but they often don't include it in their LCOE. They don't talk about extra grid infrastructure to run the power lines to wherever their installation is, or the cost of backup dispatchable power sources to power the country during Dunkelflaute. Dispatchable sources are often penalized by being forced to remain on standby when solar and wind are generating cheap electricity. So the grid operator says, no, you have to be able to jump in at a moment's notice in case the wind calms down or a cloud comes by. So they got to sit there idling and be able to jump in. And it's obviously, if somebody says, I'm not gonna, you're a taxi, I'm not, you need to be ready at a moment's notice, so you just need to sit there idling your engine all day in case I need you. Can you imagine? Yeah, try to make a living as a taxi that way, right? Wind doesn't work well everywhere. This is from Peter Zion. If you go to Zion, he has a website. You can look it up. These are from his website. I asked them if they were copyrighted. They never got back to me, so I'm assuming not. Dark red means you have good wind potential. Light green means forget about it. So you can see in the US, we have some good wind potential in the Midwest, Iowa and Texas. Okay, there's our wind channel. Some places you don't. But the problem is a lot of times the big cities are not near where the solar and wind are. And windmills also kill large numbers of valuable birds like eagles, falcons, and hawks. Technically it's a federal crime to kill an eagle, but if you're a wind farm and you say, we are going to take some mitigation factors, they kind of say, okay, you're taking some mitigation factors, go ahead, kill what you want. If you or I did that, we would be paying heavy fines and or land in jail. You can't even pick up an eagle feather, it's illegal. It's a federal crime. House cats kill great, and then the comeback is always, well, house cats kill a lot more birds. Yeah, house cats kill sparrows. Nobody cares about those. Remember Jesus said, even when a sparrow falls to the ground, your heavenly Father knows? Yeah. Why did he say that? Because sparrows were so worthless, right? The most worthless bird you can think of, God even cares about. Here's solar. Germany's up there in that light green zone, negligible, okay? Most of Europe is lousy for solar. You can put solar there, you just won't make back your investment. It's uneconomical. Germany, matter of fact, Václav Smil, yeah, here we go. Yeah, this is from his other book that I have, Numbers Don't Lie. A naive observer might conclude that the rising share of renewables, solar and wind, would usher in an era of falling electrical prices, right? Because their LCOE is so low. But in reality, the opposite has been true. And he talks about Germany and California. They have higher rates because of their solar and wind. So does South Australia, has gone big, and they like to brag about, oh, we're getting so much electricity from solar. Their electric rates are about 50% higher than the rest of Australia and about double what they are in the US. But it's solar. What about nuclear and hydrogen? Safest accidental deaths and air pollution, greenhouse emissions. Wind, solar, nuclear are all good in that respect. Natural gas is pretty good for safety. It does emit carbon dioxide, which we've talked about. How about materials used per terawatt of production? Well, nuclear is really good. Solar is terrible. A matter of fact, you don't get much more, you get about twice as much energy out of a solar cell as it takes to make it. Wind's somewhat better. It would be nice if we would put more effort into small modular reactors because, as you can see, nuclear energy accidental deaths, this includes Chernobyl, TMI, and Fukushima. Okay, the three biggest historical disasters the planet has ever seen is factored into that. Hydrogen is not, oh, by the way, hydrogen is not an energy source. It's more like a battery that you have, like your lithium battery that you have to charge up because there's no such thing as a hydrogen mine. You have to get hydrogen from water or something like that, or you can form it from natural gas. If you form it from natural gas, you're releasing a lot of carbon dioxide. And the process is very efficient, so you're actually producing a lot more carbon dioxide and getting a lot less energy out of it than you would if you just burned the natural gas. And there's so many inefficiencies in the hydrogen, producing it, transporting it, storing it. It's a poor payback. I mean, I suppose if you got windmills and solar going crazy on a hot, windy day, on a sunny, windy day, because solar actually declines output in hot weather. Maybe you could produce some, but it's not that efficient. Electric vehicle economics compared to gas. EVs are more expensive to buy, generally cheaper to charge, but only if done at home because if you charge on the road, the electric rates are about 4 times residential rates. And so there's a number of YouTube videos, real world examples, people showing you the math and real world results. If you're using commercial chargers that you actually have to pay for, you didn't get some special deal, now you can charge at home for local trips, but if you're going on a long trip, your fuel costs are going to be comparable or possibly more than gas for that same trip in an EV. And you generally need a private garage and purchase and install a charger. Demographically, the people who buy EVs are rich liberals who buy them as second or third cars, and then they keep a gas car for their long trips, and they use the EV as their going around town car. They're more expensive to insure, much more expensive to repair. Hertz, you can read about Hertz and electric cars. Long trips are much longer due to charging time and access to a charger. Even if you get to a charger, if there's 3 cars in front of you, oh boy, are you going to wait. Cold weather issues in Chicago about a week or 2 ago. There was a bunch of bricks that were supposedly EVs, but even though they were plugged into a charger, they wouldn't charge. They had to get towed to the charging station because they died in cold weather. And once an EV dies, it's hard to get it going again. And by the way, gasoline is not subsidized. I've looked into this. I can't find any subsidy that any other industry gets. So if anybody knows of some hidden gasoline or oil subsidy, please let me know. I've been looking, I can't find one. They'll say, oh, but they get to depreciate their wells. Yeah, and if Microsoft buys a computer, they get to depreciate that computer. It's the same thing, okay? It's the same kind of depreciation and depletion allowance anybody else gets, or normal business costs anybody else gets, and they claim those are subsidies. There are subsidies in developing nations. A lot of them subsidize both food and energy for poor people. Okay, they will keep the price of both of those artificially low, and the government will pay for it. But that's not the case in the US, just some developing countries. EVs, I think I'm trying to remember, I think it's 200 pounds more aluminum plus all these other minerals. These minerals are very expensive. These are also used to a lesser extent by internal combustion engine cars, but these are mostly unique to EVs, and they're very expensive, and a lot of those have to come from places that China controls, or like in the Democratic Republic of Congo, about 60% of their cobalt goes for EV batteries, and you might have seen some of those, what they call artisan mines, where they have little kids crawling in caves to fish out the cobalt nuggets. It's child labor, which supposedly we frown upon, but I guess it's okay if you're making EV batteries. Actually, your phone batteries are the same stuff, but that's a much lesser extent. That's just a little teeny thing. EV batteries are humongous. But EVs, battery technology, I'm just saying as of right now, there are some major issues with them. It may be that battery technology improves and things get better. I'm just saying for now, there's some issues. Carbon footprint. Okay, this is not meant to be totally to scale. This is meant to illustrate a principle. Miles driven carbon footprint. Internal combustion engine cars, let's just assign them a value of 1 for their initial carbon footprint. An EV starts out about 70% higher because all those minerals I mentioned and the battery take a lot of carbon to produce. A lot of carbon dioxide gets emitted making those vehicles. So they start out with a much larger carbon footprint. Now, the slope of this line is highly debatable. It depends what you're using for electricity, how it's produced, okay? If it's produced by fossil fuels, what you have in effect is a remote combustion vehicle. Not an internal combustion vehicle, a remote combustion vehicle, because the coal plant is providing the electricity to run your car. So you basically have a coal-powered car. If you have solar and wind or nuclear or hydro, then it's a different story. But the point is, this slope can vary a lot, okay? And this point generally comes in like maybe 6 or so years of driving, average driving rates when the carbon footprint finally crosses the ice footprint. And the final footprint is maybe 25% less. Given all the higher costs and the government subsidies, you get a $7,500 kickback from the government if you buy the right kind of EV. You can buy carbon offsets on the New England Carbon Exchange in the US for like less than $100. That would do the same amount of carbon offset. So from a financial aspect, it's like, wait a minute. You could spend like 1/10 the cost and get the same carbon offset just by doing that. Personally, I like the concept of a hybrid vehicle. If you think of a train locomotive, virtually all the train locomotives in North America are diesel electric. They have a big diesel motor running a electrical generator which runs, puts out electricity to turn the wheels. So there's no connection between there's no physical connection between the diesel engines and the train wheels. Those are electric motors, and they find that to be very efficient. The thing about a hybrid car is you can take advantage of regenerative braking. So, if you're in stop and go traffic, you can take some of that momentum from the car and regenerate electricity when you're slowing down to put back in the battery. So that is an advantage. And if you have a hybrid vehicle that has a battery, you can take advantage of that regenerative braking. And if it has a small battery in it, like maybe a commuter length battery, you can run, and if you plug, those are small enough you can plug them into a regular outlet at home. Don't have to get a special charger. And that could give you enough energy to maybe commute back to work. And so you could run almost all the time on electricity, and but then if you want to go to Colorado, you just put some gas in the tank and off you go, and no problems, no range anxiety. The other thing is you could use a generator, if you configure it right, you can use a generator to power your home in a power outage. You can run the internal combustion engine, basically your home generator is in your garage. So I kind of like that concept. Here's the total sources of carbon that somebody put together. Here you see cement at 3% that I mentioned earlier. Here's iron and steel at 7.2. Road transport is about 12. About half of that is light vehicles like cars and pickup trucks. So if you improve 6% by 25%, assuming an instantaneous, fairy godmother waves the magic wand, does an instant conversion. So instead of 6%, it would be 4.5%. So you'd save 4.5% out of 100 by going fully to EVs at, I don't know how many billions or trillions of dollars of cost. Here's some websites that you can go to. Here's alarmist ones and skeptical ones. I've listed more skeptical ones because this information is much harder to come by. You turn on any mainstream news or government source, you'll get this all day, every day, without fail. This information is much harder to come by, and so that's why I listed more of those. And just for a final wrap up, God's word should be our guide for all things. Humans are the reason for the earth, not parasites. God has designed a stable climate control system, which he you remember that pendulum? Yeah. At the flood, we had a stable climate system, and God came along and said, you humans are so evil, I have to take care of you. And he whacked it, gave us a flood and an ice age, but then it settled down, and you just get like grandfather clock nowadays with the sun variations and some other things. So it is a stable thing. CO2 is an integral part of God's ecosystem, not a pollutant. Fossil fuels were apparently created in the flood, so the anxiety about it got taken out of the biosphere in 1 year, so putting it back over several hundred, you can assess for yourself. Global temperatures are driven by a variety of things, and we have no clue about many of them, and we should continue to listen to both sides, testing everything. And I just want to make a closing statement. Our God, you're probably familiar with the song, Our God is an Awesome God. I want to say he's an awesome engineer too. That's all. I'm done.